The light in this question starts out unpolarized with some initial intensity. So we start out with some intensity I0 of our unpolarized light. Then the light goes through a polarizer with a vertical transmission axis. So after that first polarizer, we know that a polarizer will cut unpolarized light intensity by half. So if we start out with light with intensity I0 and then it goes through the first polarizer, after the first polarizer, the intensity will be half of that initial intensity. So we'll call that I1. So after that first polarizer, we have half of the initial light intensity. Then there is a second polarizer, and we know that its polarization axis is 45 degrees away from the axis of the first one. So we have an angle of 45 degrees. So then to find out the final intensity of the light after it goes through this second polarizer, we'll call that intensity. So this one was I1, we'll call this one I2. I2 is going to be equal to I1, according to Malleus's law. It will be the intensity after the first polarizer times the square of the cosine of 45 degrees, since that's our angle between the two polarization axes. So the square of the cosine of 45 degrees, and then we multiply that times I1. But we know that I1 is 1/2 of the original unpolarized light intensity, and then we have to multiply that by the cosine of 45 degrees squared. So we take the cosine of 45 degrees, square it, and then multiply that by 1/2, and we get a number that is equal to 0.25, and then that's times I0. So after the second polarizer, the intensity of the light that makes it through everything is going to be 1/4 of the original unpolarized intensity.